Good afternoon, my dear students. Today I brought an interesting lecture on the gas chromatography. In this lecture, we should cover the following topics: the introduction of the gas chromatography, principle involved in the process, the types of the gas chromatography, advantages of the gas chromatography, disadvantages or the limitations of the gas chromatography, and the various components of the gas chromatograph. What is the learning outcome of this lecture? You will be able to understand about a brief detail of the gas chromatography, including the introduction, principle involved, various types, advantages, limitations, and the components of the gas chromatograph. So let's start. What is gas chromatography? Gas chromatography is an important type of the chromatography in which the gas is a mobile phase which moves on the stationary phase that can be solid or the liquid. And the chromatography is a separation and a purification technique in which we can separate the constituents present in the sample on the basis of their affinity or the solubility between the two phases when they come into the contact to one another. We can define the gas chromatography as it is a process of separating the component from the given sample, and it can be the drug, it can be inorganic material, by using the gaseous mobile phase. It involves a sample being vaporized in the gaseous form and injected onto the head of the chromatographic column, where we just fix our stationary phase. The sample is transported through the column by the flow of the inert gaseous mobile phase. The column itself contains the liquid stationary phase, or it can be the solid stationary phase, which is adsorbed onto the surface of this inert solid. The father of the modern gas chromatography is the Nobel Prize winner John Porter Martin, who also developed the first liquid gas chromatograph in 1950. What is the principle involved in the gas chromatography? It works on the adsorption phenomena as well as partition phenomena depending on the stationary phase used in the column. So on the basis of the stationary phase, the principle involved the adsorption as well as the partition. So if the stationary phase, if we go for selecting the stationary phase, solid, if we go for selecting in the column, that is solid. So the phenomena works and the principle involved, that is adsorption, because it depends on the affinity of the constituents toward the solid stationary phase. So the adsorption principle involved, and if we select the stationary phase, liquid, if our stationary phase in the column is liquid, then it involves the principle partition phenomena, because the constituent separation depend on the basis of the solubility difference between the liquid phase. Understood? So the solubility difference is there among the constituents in the liquid phase, that will be the partition principle. So on the basis of the stationary phase selected in the column, both the principle involved in the gas chromatography. Now let's see the different types of the gas chromatography. We can divide the gas chromatography into two types on the basis of the principle involved and the stationary phase used in the column. The first is gas-solid chromatography, which can be abbreviated as GSC. The meaning is simple. It is gas is always a mobile phase, and we have selected the stationary phase solid SC chromatography. So here the mobile phase is a gas while the stationary phase is a solid. It is used for the separation of the low molecular gases. Example, the air components, the hydrogen sulfide, carbon disulfide, carbon dioxide, rare gases, carbon monoxide, and even the oxides of the nitrogen. So it is based in the adsorption phenomena. Now the second one is gas liquid chromatography, which can be abbreviated as GLC. Okay, so here the gas is a mobile phase while the stationary phase is the liquid, which retained on the surface on an inert solid by the adsorption or the chemical bonding. Means always there is a supporting material, that is the inert material in which the liquid is fixed. So in that inert material, it can adsorb the constituents as well as the solubility of the constituents towards the liquid phase is the basis of the separation, that is the partition phenomena. What are the advantages of the gas chromatography? The technique has the strong separation power, and even the complex mixture can be resolved into the constituents. Meaning if we are having several constituents in the complex mixture, it can be easily separated in this method. The sensitivity of the method is quite high, meaning the little amount of the constituent can be easily separated in this method. It gives good precision and the accurate results. The analysis is completed in a short period of time. Means once you inject your sample, it goes through passing through the column and we have the result recorded. The cost of the instrument is relatively low and its life is generally long. It's a one-time investment, and if we compare the cost of the instrument, so that is relatively low and its life is generally long. The technique is relatively suitable for the routine analysis where we are getting the research point of view. We are synthesizing the compound and see whether the constituents you are able to synthesize, they are there in the sample and they can be separated by the method. In the routine analysis, you can use this technique. Now we see the limitations or the disadvantages of the gas chromatography. The sample analyzed are limited to those that are volatile in nature or can be made volatile, because the mobile phase is the gas, and if we want the sample to be analyzed in this method, your sample to be easily vaporized or converted into the vapor, and they should be volatile in nature and can be made volatile easily. For those samples, only this method is to be used. But those samples which are not made volatile or which are not volatile in nature cannot be separated by this method. The sample must be thermally stable to prevent the degradation when heated. It is very important. Whether you have made your sample volatile, but it should not be degraded. Otherwise, the other products are formed and your sample is destroyed. Cannot be used to prepare the samples for the further analysis once separated. If you have separated your constituents by this method, you cannot do the further analysis. The problems can be encountered when injecting the sample. The problem may occur when you inject your sample and convert into the volatile form. So these are the limitations of the gas chromatography. Now we discuss the various components of the gas chromatography which required for the instrumentation. The instrument used to analyze the sample on the basis of the gas chromatography is called gas chromatograph. The first component of the gas chromatograph is the carrier gas. Carrier gas is the inert gases. For example, the helium, which is very common in the gas chromatograph, the nitrogen, hydrogen, argon. Gas from a high pressure cylinder having the pressure regulator. The pressure is to be taken 40 to 80 psi. That's the first component, carrier gas. The next component is the sample injection part, which is the micro syringe in which your sample is injected in this carrier gas. The third part is the column, which is the major part where the separation takes place. It is made up of stainless steel or the glass or the Teflon. It is 2 to 50 meter. We have the range of the column and it is coiled column which is used in the gas chromatograph. Next component is the detectors. Several detectors are there. Their principles are different. We should see each one of the principle of the detector used in the gas chromatograph. The one of the common detector, that is thermal conductivity detector. Then we have a flame ionization electron capture detector, the flame photometric detector. So the detector role is to convert the energy into the signals. And next component is the amplifier and the recorder, which is usually the same. So we have to talk about all these components of the gas chromatograph. Then we can understand better the gas chromatograph instrument. So let's see the components in a detail which is required for the instrument gas chromatograph. The cylinder or the gas tank is fitted with a pressure controller. So by using the gas cylinder, there is a pressure controller to control the pressure of the gas, which pressure gauge indicates the pressure. A molecular sieve to transfer the filtered dry gas, and a flow regulator is there to ensure the constant rate of flow of the mobile phase to the column. So there is a pressure controller, flow regulator to check all the gases coming and passing to the column. So the carrier gas we have selected, it meet the following criteria, as it should be chemically inert, it should be cheap and readily available, should be of high quality and not cause any fire accidents. That's why the helium is more common as compared to the hydrogen, and it should give the best possible results, should be suitable for the sample to be analyzed and for the detector also. So all these conditions or the criteria for selecting the carrier gas are hydrogen, helium, nitrogen and carbon dioxide can also be used, but helium is more common. Hydrogen has low density and the better thermal conductivity. However, it reacts with the unsaturated compound and it is inflammable and explosive in nature. So it is dangerous to use the hydrogen. Nitrogen is inexpensive, but it gives reduced sensitivity. Helium is most preferred gas. Helium is very common to use in the gas chromatograph. The inlet pressure ranges to 10 to 50 psi. That is can be 40 to 80 psi also. Flow rate 25 to 150 ml per minute in the packed columns and in 2 to 25 milliliter per minute for open tubular columns. So the pressure goes on ranging, it should be 40 to 80 psi or somewhere it is 10 to 50 psi. Sampling unit or the injection port is the second component. It is attached to the column head. Since the sample should be vaporized, the injection port is provided with an oven that helps to maintain its temperature 20 to 50 degrees centigrade above the boiling point of the sample. So it maintains the temperature also, so it can go for vaporizing. The gaseous samples may be introduced by the use of gas-tight hypodermic needle, that is 0.5 to 10 ml capacity. So these are the syringes for the liquid sample. Micro syringes of 0.1 to 100 microliter capacity may be used. So mostly this is the injection port in the form of micro syringe. It has this capacity to inject the sample into the carrier gas. Now the third component, and which is the major part of the separation, is the column. The column are of different shape and the sizes, that includes U-tube or the coiled helix type. The coil type is mostly used in the gas chromatograph. They are mainly made up of stainless steel, copper, aluminium, glass, and the plastic, Teflon, nylon. Its main function is to provide the mechanical support to the liquid phase. We have the supporting material when we go for using the liquid as a stationary phase. An ideal support should have a large surface area. Chemically inert should get uniformly wet with the liquid phase, should be thermostable. So all the criteria is there for using the supporting material in a liquid stationary phase, and commonly used solid phases are diatomaceous earth, kissel glass beads, the porous polymers, sand, the pieces of the bricks, stones. So these are the common supporting material which is used in the gas chromatograph. Now we see the different types of the column used in the gas chromatograph. The two general type of the column are packed column and the capillary column. The packed column, which length is 1.5 to 10 and usually it is 3 meters. Generally, it goes with the range of 1.5 to 10 meter and usually it having the 3 meter length. Internal diameter is 2 to 4 millimeter. That is the packed column. If we are using the solid as a stationary phase, the columns are the packed with the solid stationary phase, adsorbent or the porous polymers. And if we are using GLC, they are densely packed with the finely divided solid support material coated with the liquid stationary phase. The second is the capillary column. Its length ranges to the 10 to 100 and we have the 300 meter. It can goes with the 300 meters length. Usually having the diameter 0.1 to 0.5 millimeter. Now capillary column can be divided into two types. The first is wall coated open tubular column and the second one is surface coated or the support coated open tubular column. The wall coated column, which consists of the capillary tube whose walls are coated with the liquid stationary phase, and the direct coating of the liquid stationary phase into the wall of the column occurs. So in this we can say it's the wall coated open tubular column. It is also said W cot. Here it is written wall coated open tubular and surface coated open tubular. So the inner wall of surface coated column, it is lined with the thin layer of the supporting material such as the diatomaceous earth onto which the stationary phase has been adsorbed. It is sometimes called plot, porous layer open tubular column. But they are very difficult to make it as the surface coated open tubular column. So surface coated open tubular columns are generally less efficient than wall coated open tubular columns. Both type of capillary columns are more efficient than the packed columns. If we compare through the packed columns, they are more efficiently used, but the Ascot column is less used. It is very difficult to make. So W cot is most common in the gas chromatograph. So you can see here by the diagram, the porous layer open tubular column, that is the surface coated only, that is also said to be the porous layer. So this is the plot and the packed column in the next diagram. And the third one is wall coated open tubular column. So we have the various types of the column having the different shape, and the packed and the capillary column according to the stationary phase. For the coiled column is largely used because U shape is also there, the straight is also there. The straight column is used for the small purpose. U shape is a medium column and the coiled is the large column. So we have seen almost these important components of the gas chromatograph in this lecture. In the next lecture, we are going to talk about the detector and the instrumentation gas chromatograph, including the working, analysis, and the applications. Thank you and take care.